Hi, welcome to lesson 8.2, Transformations of Logarithmic Functions. Now that we have looked at the inverse of exponential functions, which is the logarithmic function, we're now going to look at transformations of logarithmic functions, and the goal for today is to determine the effects of varying the parameters of the graph of y equals a log of base 10 of k quantity x minus d plus c. Meaning, we're going to determine how to graph transformed functions. In determining what transformations do to logarithmic functions, we'll start off looking at vertical stretches and compressions. So the equation would be in the form y equals a log x. Remember, where the base is 10, it's understood if it's not written. And what we want to do is take a look at the points 1/10 and -1, 1, 0, and 10, 1 on this original graph, which is this dotted graph right here. Take a look at the main points. So 1/10 and -1 is right here. Obviously 1, 0 is right here where they all intersect, and then 10, 1 is right here. So for a vertical stretch or compression, we want to take a look at these 3 points to see what happens to them. So if we take a look at this function y equals 2 log x, what does the 2 do to a logarithmic function, or basically any function when we're dealing with transformations? That 2 will multiply all the y values by 2. So this point of 1/10 and -1 becomes 1/10 and -2, which is right here. Notice that it's vertically below this point of 1/10 and -1. This point of 1, 0 stays 1, 0 because 0 times 2 is just 0. And this point here of 10 and 1 becomes 10 and 2. For this graph of y equals 5 log x, it's very steep here, and it goes down below where we would be able to see this on the graph. But this point of 1/10 and -1 would become 1/10 and -5. So if we were to draw a line vertically through here, we would see that this graph would extend down to 1/10 and -5. This point 1, 0 stays at 1, 0 because 0 times 5 is 0, and this point of 10, 1 becomes point 10, 5. And then here, when we're multiplying by -3, this point of 1/10 and -1 becomes 1/10 and 3. If we were to go directly vertically up, we see that that's the point 1/10 and 3. Sorry, 1/10 and 3. 1 and 0 stays the same, and this point of 10, 1 becomes 10, -3. And now we'll take a look at vertical shifts or vertical translations. Here's the original graph of log x. Again, we'll take a look at these 3 main points. You can just focus on those. And the form of a function that's undergone a vertical translation is y equals log x plus c. So here, if we're going to add 2, all of these points are going up 2. So this point of 1/10 -1 becomes 1/10 1. This point of 1, 0 becomes 1, 2. This point of 10, 1 becomes 10, 3. And then here, if we're subtracting 3, this point of 1/10 -1 becomes 1/10 and -4. 1, 0 becomes 1, -3. And 10, 1 becomes 10, -2. when we focus on horizontal translations, they have the form of y equals log x minus d. The original equation again is this, so the original function is this dotted graph again here. And we've got main points. Here's 10, 1, 1, 0, and 1/10, negative 1. So for this graph here, y equals log of x plus 3, notice that this point is moved to the left 3. This point of 1, 0 moves to the left 3. And this point of 10, 1 moves to the left 3. Then this graph, y equals log x minus 2, this point moves to the right 2. This point 1, 0 moves to the right 2. And this point 10, 1 moves to the right 2, to 12, 1. And this graph, this is log of negative x plus 1, and generally we factor out that negative, so it becomes negative x minus 1. So it's been reflected in the y-axis and then translated to the right, negative 1. So this point of 1/10 and negative 1 would become negative 1/10 and negative 1, and then it gets translated to the right, so it becomes 9/10 and negative 1. This point of 1, 0 would become negative 1, 0 with the reflection, and then the translation to the right brings it back to the origin 0, 0. And this point, 10, 1, would become negative 10, 1, and then with the horizontal translation to the right one, it becomes negative 9, 1. And for the horizontal stretch of compression, the form of the equation is y equals log kx. Again, we'll take a look at these main points of 1/10 and negative 1, 1, 0, and 10, 1. And remember that that k value will divide all the x values. So for this graph of y equals log 2x, all the x values are being divided by 2, so this point of 1/10 and negative 1 becomes 1/20 and negative 1, is even closer to the y-axis. This point of 1, 0 becomes 0.50, and this point of 10, 1 becomes 5, 1. And then here is the graph of negative 0.5x. So the negative reflects it in the y-axis, and then 0.5 we're dividing by a half, and when you divide by a half you flip and multiply, so we're basically multiplying all the x values by 2. This point of 1/10 and negative 1 becomes negative 1/10 and negative 1 because of the reflection in the y-axis, and then it becomes negative 1/5 and negative 1 with the horizontal stretch. And then this point 1, 0 becomes negative 1, 0, and then with the horizontal stretch by 2 it becomes negative 2, 0. And this point of 10, 1 would become negative 10, 1, and then it gets stretched by 2, so it's actually at negative 20 and 1, which is off the grid. Okay, so what I'd like you to do now is I'd like you to examine each of these graphs below here and determine the transformations for all of those. They could have any combination of reflections and stretches and translations, and please write the transformations in order from left to right in these boxes here according to these grids or the graphs above here. And so pause the video and work on that, and then you can check with your classmates when you get to school tomorrow.